Hello, my name is Kylie Antonik, and today I'm going to make a supplemental video about Newman projections in order to help kids who are in organic chemistry try to understand how and why we use them. As you may or may not know, sigma bonds of a molecule are free to rotate, and they change their conformations depending on their positions when they rotate. Normally, we portray bonds in what's known as a line or skeleton notation. This is where the main carbon chain is in the plane of the page or the board or the screen, depending on where you're looking at the molecule. However, this does not show exactly how the bonds are situated on the carbon atoms or the carbon molecule in the complete chain. So therefore, we have what's known as a Newman projection, and we're going to take a look at how a Newman projection shows those bonds. In order to display orientation on a molecule, we use what's known as a Newman projection. What we do is we look down the proximal end of a carbon-carbon bond to the distal end, and we portray the functional groups and their orientations. Here are some examples of Newman projections, just to give you a clear picture of what a Newman projection actually is. So right here, this is supposed to be the first carbon, or the carbon on the proximal end of the carbon-carbon bond we're looking at. And you're supposed to be looking at the front carbon, which is right here. This is the circle, and these are the bonds coming off of the first carbon, and they originate from the center of the first carbon. However, behind this circle is supposed to be the second bond. So we don't actually get to see the second bond, but we actually get to see the groups coming off of the carbon and the different conformations. So these are different conformations right here. And we'll talk about what staggered and eclipse and all that is later, but these are just the pictures. And you can obviously see how they're very different, and we're going to talk about why they're different. One of the conformations in a Newman projection is known as what's called staggered. This is where the electrons repel each other as much as they can because they are the same charge, and as we know, like repel. So when the electron clouds get too close, there's more steric hindrance happening. So the lowest energy is when they're at what's known as a dihedral angle of 60 degrees. This is the furthest apart that they can be before they start approaching each other again. Here is an example of a staggered conformation. So we have 3 hydrogens on the first carbon. We have 2 hydrogens and a chlorine atom on the back carbon. As you can see, all of these atoms are spread apart enough that they're not too close to one another on either side, and they're all at a dihedral angle. This is so none of the electrons get too close to each other, and they do not sterically hinder each other. We also have what's known as an eclipsed conformation. This is the highest energy that a molecule can be in because of the overlapping molecules. The potential energy rises as the bonds on both carbons overlap, and once it reaches that they're completely in line with each other, that's the highest energy, and as they continue to turn and go back to a staggered conformation, the potential energy goes back down. This is what an eclipse conformation looks like. Compared to the staggered, the atoms on the carbons are directly in line with each other, and therefore they are very sterically hindering each other, especially the bigger atoms like this chlorine here. And their electron clouds are going to repel each other, and they're going to actually start to go back into the staggered conformation. However, this is what the eclipse conformation looks like because they're directly in line. To go along with staggered conformations, we have 2 different types. We have what's known as an anti-configuration and a gauche configuration. When something is in anti-configuration, this is the lowest energy possible because either all hydrogens or the biggest groups or atoms on the molecule are as far apart as they possibly can be. Gauche conformation, on the other hand, it's a little bit higher, but it's not the highest energy possible. But this is when either all the hydrogens or the bigger groups or atoms are closer to each other and they create more steric hindrance, but again, this is not the highest energy because that would be the eclipsed conformation. Let's take a look at some examples to get us a little bit more familiar with anti and gauche configurations. So this is an anti configuration of butane. Here we have this methyl group and this methyl group, and obviously, as we can see, they are as far apart as they can be. This gauche configuration, we have the two methyl groups, but they're a lot closer now, and because they are relatively big molecules, they're going to start sterically hindering each other, and this is why the gauche configuration is a higher energy than the anti-configuration. Down the bottom here, we have 3 different examples of the anti, the gauche, and the eclipsed conformations. This right here, this first one, is an anti-configuration. It's obviously the same molecule as up here. This is the anti-configuration. We're going to have one methyl group at the top and the others all the way at the bottom. The second one right here is an eclipsed conformation. The molecules are so close together that they're very sterically hindered at this point, and they're going to be at a very high energy that they're actually going to start making their way and rotating into a staggered conformation. This over here is the gauche conformation. Here we have 2 methyl groups, and they're 60 degrees apart, but they are still right next to each other, and therefore there is still some steric hindrance. Here are 2 more examples of anti and a gauche configuration. This is an anti-configuration. The CH2 molecules right here, they're on opposite ends. They're obviously as far apart as they possibly can be. However, this is the gauche configuration. The CH2 molecules are right next to each other, and obviously they're sterically hindering each other.